here to present the project and how a flame is produced, and this project was created by Alan Alda. So here we have a picture of a flame, and what we normally do is light a candle, and this whole process and how a flame is produced is started off by the wax melting, the wax by the candle. It's melted by the heat, and it's turned into liquid. The liquid then rises up through the wick, which is right here, this region in which the flame is on right now. It rises up through the wick through a process called capillary action. Capillary action is the process by which liquid rises up, opposing the force of gravity, going against the force of gravity. But once the wax that is melted and turned to liquid goes up through the wick, it is then dispersed all around the flame by the gases that are present in the flame. Before it's spread out, it turns into a gas through a process called vaporization. Vaporization is the process in which a liquid is turned into a gas.
As the liquid wax turns into a gas, molecules called hydrocarbons right here are released. So a hydrocarbon in this diagram is one carbon atom with other hydrogen atoms attached to it, and that creates one molecule known as hydrocarbon. In a flame, oxygen in this diagram is made of two oxygen atoms, which makes an oxygen molecule. So in a flame, oxygen is needed, and its purpose is to break up these hydrocarbons. Once the hydrocarbons are broken up, light is emitted, and the result is the light, or color here, that you see in the flame. A flame normally consists of a dark cone region, here, a yellow region, and a blue region.
As Sarah just explained before, hydrocarbons are broken up by the oxygen molecules. The hydrocarbon molecules and the oxygen molecules take up the majority of the flame. However, there are many other molecules there too, and there are other colors present throughout the flame. However, the yellow, blue, and dark cone region are the main ones present that you can mainly see. So in the dark cone region, there is very little oxygen that is present. Due to this, very little hydrocarbon molecules are broken up. Because very little hydrocarbon molecules are broken up, very little light can be emitted. So in this blue region, there are many oxygen and hydrocarbon molecules. And because of the great amount of oxygen molecules breaking up the hydrocarbon molecules, the light that is present would be close towards the end of the visible light spectrum, and blue is close towards the end of the visible light spectrum. Because there are a great amount of oxygen molecules breaking up hydrocarbon molecules, it will also be the hottest region in the flame.
Although the majority of the flame is normally the yellow region, hydrocarbons from the dark and blue regions combine together, and these combined molecules from the dark and blue regions then are burned by the oxygen, resulting in a yellow light, right here, that takes up most of the flame.
As we have said, the flame consists mainly of hydrocarbons and oxygen molecules. However, there are other molecules present as well. In a flame, because it is so hot, molecules are moving around and bumping into each other.
A good example to visualize is a pinball machine, which you guys play in an arcade. So think of the pinballs as like the molecules, which are like, think of molecules as the pinballs bouncing against each other, just like they would in the flame.
Thank you for watching.
I hope you enjoyed it.